As you can see that first of all, I've imported all the necessary libraries, importing pandas as PD, numpy as np, and all the matplotlib libraries. And as explained that Boston data is available inside the sklearn. So from sklearn.datasets, I imported load Boston and mean square error just to measure the error iteratively, and train test split to split the training and testing data of x and y, and min max scaler to for feature scaling of the of the independent variables, for the feature scaling of independent and dependent variables both. Okay, and HTML to display the animation, and Boston is equals to load Boston, that loads the Boston data into the variable Boston. And what we want to do, we want to create a data frame, so we have done features is equals to pd dot data frame, so that creates a data frame. And in the data frame, the data which is loaded is Boston dot data. And if I look at the Boston data, then the name of the columns is feature names. So I call the feature names from Boston, so it's called as Boston dot feature names, and I'm storing it columns. So what we'll do, automatically all the names will come in the column CRM, ZN, Indus, and so on, and a data frame will be created successfully. And I've typed here features just to display the features in the form of a data frame, and this is here, which has 506 rows and 13 columns. Now I'm interested in the target variable now. So target is equals to pd dot data frame. Again, I'm creating a data frame that contains only one column, and the data that I want is target. So Boston dot target is the data, and the name of the column is target. So in this one, I'm displaying the target data, and it's in front of us. And likewise 506 by one column, and 506 by 13 columns. So 13 independent variables and one dependent variable, and entries are 506. So what I want to do is I just want to make a whole data frame. By whole data frame, I mean I am concatenating the target with the independent variable data frame. So what I am doing, concat what features and target. So this will combine both the tables. X is equals to 1, that means row by row. So I'm now printing the data frame. In the data frame, it is clearly visible that there is a target now concatenated with the independent variable matrix. Now describe the statistical function that shows the count, mean, standard deviation, the minimum value of that row. What is the 25%? That means first quartile, second quartile, third quartile, and the maximum value. So these are the statistical parameters that are displayed when you type data frame dot describe. And we have rounded off to the two numbers after the decimals. So that's why round decimals is equals to 2. And there is the data here. Fine. Now, what I want to do next is this df.describe, for just for the point of view from knowledge. The thing which is useful to hear us is correlation. Now, we have Carl Pearson's coefficient of correlation, that is called as Pearson. So I'm applying the correlation function on the data frame, and I'm storing it on CORR correlation. What I want to do is I just want to focus on the value, the extent of dependency, without being worried about if there is a negative dependency or positive dependency. So I don't want to see there's a negative correlation or positive correlation. I just want to see the amount of correlation. So I've called the absolute value, and CORR1 is the variable that stores just the absolute values of the correlation. So now we don't know whether they are positively correlated or negatively correlated. They are just correlated by the extent of 0.388, 0.36, and so on. So what I want to do, I want to arrange it in the descending order. So I'm zipping the correlation values with the features, and what I'm doing, sort reverse is equals to true. That means this will sort in the descending order. And descending order, the reason of zipping is if we sort without zipping, then what will happen, the correlations will be sorted, but the features will be as it is. So that gives the wrong information, like there will be changed value of correlations of each independent variable. So while zipping and sorting, what it does, it actually takes up the whole the value as well as the column, and then sorts it in the descending manner. And unzipping, and now the graph is there in front of you. So this is absolutely simple, drawing the graph. np dot arrange length of label, and what is label, we need to understand what is label. You can see here, while unzipping, correlation and the labels. These labels are nothing but the independent variables. So length of independent variables, nothing is the index, and figure size 10 comma 5. This is the aspect ratio. That means the this is the horizontal is 10 and vertical is 5, and plotting the bar graph with index numbers are 0 1 2 3 4 and so on, and at each index plotting the values of correlation, and width is 0.5. X label attributes, Y label correlation, X ticks. Now what it does, it replaces the index with the labels. Without this the horizontal entries would have been 0 1 2 3 4, but I don't want this. I want the name of the features, so I'm replacing the index with the label and plt dot show. So I can see that lstat has a maximum correlation with the target attribute. So I'm taking it as independent variable. We are doing simple regression, so I'm taking it as lstat as the value of x, and target as the value of y, and scaling them using the min-max scaler that scales everything between 0 and 1. uh, Fine. So the scaling has been done. Now splitting the x and y into training and testing, and testing is 20%, training is 80%. So splitting into testing and training, and now defining the what we want to do. We want to make a gradient descent function. For this, we need to calculate error and the update. So by checking the error, the sum of y predicted value minus actual value, so that will give us the error. If error is less than the threshold, so that is okay, but if it's greater than the threshold, we need to update the values of MNC continuously. So the update function has been made, uh, which continuously updates the value of MNC and then returns to the gradient descent. If it is less than threshold, then it is that prints as done gradient descent. So now time magic function that shows 176 milliseconds requires. Now this is the animation function. Animation function is absolutely simple, where you have animation.func animation, where some instead of your initial function, I've just set ax dot set limit from 0 to 1, y from 0 to 1, and so this will be now new frames will be superimposed on the previous one, giving us the effect of animation. Now what I want to do is I want to check whether my predictions and the actual value, they how much they are matching. So ypred is the variable that I've made, m slope into x test. So for all the x test entries, it generates the entries of y prediction. And what I want to do, I want to inverse transform, so that I want the actual value of y. And you can see here we have made the table y prediction and y training that shows how much the values resemble each other. So that is the project. Thank you so much.